This is a demonstration of the identification of substances by physical properties. In Part A, we're going to be looking at solubility. Our first solubility test will be of naphthalene. Naphthalene is also known as mothballs. First, we're going to put 2 to 3 milliliters of DI water in one test tube, 2 to 3 milliliters of cyclohexane in another test tube, and 2 to 3 milliliters of ethyl alcohol in our third test tube. Once all our liquids are in the proper labeled test tube, we're going to put a few small crystals of our naphthalene in each one. We're then going to take a rubber stopper and place it in the opening of each test tube, and one by one shake our test tubes in succession. Doing this will allow us to see which substance our naphthalene is soluble or insoluble in. It may be difficult to see, but there are crystals still remaining in our DI water test tube. Now we'll complete the same procedure with our cyclohexane test tube. Right away, the naphthalene dissolves really quickly in our clear colorless solution. There are no remaining crystals. We are fully dissolved. And now we take our final test tube of ethyl alcohol and naphthalene and shake just like before. And just like with the cyclohexane, the naphthalene quickly dissolves in our clear, colorless solution. Now we're going to test the solubility of toluene, which is a liquid. We're going to follow the same procedure that we did before, adding 2 to 3 milliliters of water, cyclohexane, and ethyl alcohol to the respective labeled test tubes. And we're going to add an equal amount of toluene to each test tube this time. With our toluene added to each test tube, we're going to stopper and shake and see if our toluene dissolves in our solvent. Starting with water, we see 2 distinct layers formed between the water and the toluene. Next, we're going to stopper and shake our test tube with toluene and cyclohexane. We see no layer like we did in the water. It is a clear, colorless solution. Now we're going to stopper and shake our ethyl alcohol and toluene test tube. And just like our previous test tube, we have a clear, colorless solution. Now we're going to move on to our unknowns. Our solid unknown, 1. And just like with naphthalene, we're going to put 2 to 3 milliliters of water, cyclohexane, and ethyl alcohol in the respective labeled test tubes. And then we're going to put a couple of crystals of our unknown into each one, stopper, shake, and see if our unknown is soluble in each test tube. As you can see, we still have crystals of our unknown visible in our water test tube. After shaking our cyclohexane and unknown test tube, we see that all our crystals have fully disappeared. After shaking the test tube that has ethyl alcohol and our unknown, we again see no crystals. Our final solubility test will be of our unknown C. Again, we're adding 2 to 3 milliliters of water, cyclohexane, and ethyl alcohol in labeled test tubes. This will be followed by 2 to 3 milliliters of our unknown C. Once our unknown has been added to each test tube, we're going to stopper and shake and see if our unknown is soluble. Just like we saw with toluene, our unknown C creates 2 layers when added to water. When we shake the test tube that has cyclohexane and our unknown liquid, we get a clear, colorless solution. When we shake the last test tube with ethyl alcohol and our unknown, we get a clear, colorless solution. Moving on to part B, we're going to find the density of our unknown solid and our unknown liquid. With our weigh bow on our balance plate, we're going to tare or zero our balance. And then we're going to slowly and carefully weigh out 1.5 grams and record the mass. Once we have 1.5 grams and we've recorded the mass, we're going to take a 10 milliliter graduated cylinder and fill halfway with deionized water. While adding the water, we're being very careful to not leave any water on the sides of the graduated cylinder so that our solid won't stick to the sides when we try to add. Once we finished adding our water, we want to make sure that we're carefully recording the volume. It may be difficult to see because of the angle, but the bottom of the meniscus is at 5.1 milliliters. Next, we're going to add our 1.5 grams of our solid unknown to our graduated cylinder. With gentle taps, we're going to try to get all of our solid to the bottom of the graduated cylinder. After we see that gentle taps are not making all of our solid go to the bottom, we're going to add 2 drops of soap solution to force the rest of the solid to the bottom of the graduated cylinder. Once all our unknown solid settles to the bottom, we're going to record the new volume in our graduated cylinder. Our meniscus is at 6.1 milliliters. Now we're going to find the density of our unknown liquid C. First, we're going to take a 50 milliliter graduated cylinder and find its mass. We're going to record the mass. First, we're going to measure 10 milliliters of our unknown liquid and add it into our graduated cylinder that we just weighed. After we add our liquid, we're going to again measure the mass and record the results. Moving on to part C, we're going to find the melting point of our unknown solid. We're going to add a little bit of our unknown solid 1 to a clean, dry watch glass. And then using the bottom of a test tube that is also clean and dry, we're going to gently crush our crystals. Once our crystals are crushed, we're going to use a capillary tube that is closed at one end and open at the other. And then using the capillary open side down, we're going to push it into our crushed solid. This will force our solid crystals into our capillary tube. To get our solid to the bottom of the tube, we gently tap our capillary tube on a surface. Once we have about 5 millimeters of solid in our tube, we can move on to the next step. We take our capillary tube and using a rubber band, attach it to a thermometer. We lower the thermometer and capillary tube into a 250 milliliter beaker filled with water. Then we light our Bunsen burner so we can heat our water and measure our melting point. We slowly monitor our capillary tube until we see our solid begin to melt. We finish our recording when the solid has completely melted. To aid in the boiling of the water, we're going to add 3 boiling stones to our beaker. At 51 degrees Celsius, we start to see our solid begin to melt. And it's a pretty quick transition from being completely solid to completely melted. We end our measurement at 52.5 degrees Celsius. The last part is part D. We're going to find the boiling point of our unknown liquid C. First, we're going to measure 3 milliliters of our unknown liquid. Now we're going to prepare our 2-hole rubber stopper that has a slit. The hole with the slit will be fitted with our thermometer, and the second hole will be fitted with a right angle bent glass tube with rubber tubing to drain. Next, we're going to put 2 boiling stones into our test tube. Then we're going to stopper our test tube with our prepared 2-hole rubber stopper and thermometer. We're going to position our thermometer at the surface of our liquid. Next, we're going to position our test tube in a 250 milliliter beaker filled with water and clamp it in position. When everything is in position, we'll add 3 boiling stones to our beaker. Then we're going to watch the liquid in our test tube until we see boiling, and record the temperature in which our unknown boils. We start to see boiling at about 64.5 degrees Celsius. This was identification of substances by physical properties. Thank you for watching.